Hello students, welcome back. We have been discussing about queues. Now in this session we'll discuss about doubly ended queue, or they are also called as D queues, right? So D queues. So what is doubly ended queue? Now in a queue, let's say we have this queue. This is our queue, front and rear. This is data array. Let's say there is an element present on zeroth location, that's why f is equal to 0 or is equal to 0. In this queue, the NQ operation or insertions happen from the rear end, right? When we do insertions, we do insertions from only rear end, and we do deletions or perform DQ operation only from front end, That's the normal queue, right? Or that's the linear queue. So now in DQ we can perform these operations from any end. That means I'll write here in normal queue, normal or linear queue, linear or normal, linear or circular queue. So NQ from rear end only, and DQ means deletion DQ. This DQ means double ended queue. This DQ operation means deleting an element from the queue from only front end. So in normal queue, NQ is done by using rear end only, and DQ is done at front end only. That's the normal queue. In doubly ended queue, NQ operation can be done from both end. I can do NQ from both end, and I can do DQ. That means I can perform deletion operation from both ends, right? So that's the doubly ended queue. These NQ and DQ operations can be performed from both ends. That means I can do NQ from rear, right, like a normal queue. I also can do NQ from front, right? NQ from front was not done in normal queue, right? And I can perform DQ from front as well as from rear, right? So let us see how that doubly ended queue can be implemented. So the operations which I can perform on doubly ended queue are, so NQ operations from rear end, that is normal, that's like a normal, and NQ operation from front end, that was not in normal queue, right? So DQ operation from front end, that's a normal DQ. In normal queue also we perform DQ from front end only, but DQ from rear end was not possible, or we are not performing in the normal queue, right? So these two operations, NQ from front and DQ from rear, they are done only in doubly ended queue. That means I am able to perform NQ as well as DQ from both ends. That's why it is called as doubly ended queue. Now we will implement this doubly ended queue by using circular queue, right? So we'll use circular queue to implement this doubly ended queue. So let's see the data structure is same. The data structure we used for linear queue as well as circular queue, same data structure will be used for, same ADT, rather abstract data type, will be used for doubly ended queue. This is our doubly ended queue where we have front and where we have rear. When the queue object is created, we will initialize it by setting f and r to -1. Now NQ operation. NQ operation, when we perform NQ for the first time, right? When we perform NQ we'll perform it from rear end, like normal, right? In normal queue we perform NQ from rear end. So when we perform the NQ operation for first time, we will set F to 0, R to 0, and we'll insert an element there. Same like normal queue. See, this is I think almost 13th or 14th video on queues. So you can watch the previous videos regarding which are related to NQ operation, DQ operation, or normal queue, circular queue, right? So everything is explained in detail. So here I'm skipping the detailed explanation. So briefly I'm telling. So when this is the first NQ operation, F is equal to 0, R is equal to 0. Let's say we inserted 10 here. Right. Now the subsequent NQ operations, we increment R. Now this is circular queue, right? Circular queue. We are using circular movement to front and rear. That's why it is a circular queue. So R is equal to R plus 1 mod size, which is the formula for giving circular movement to R. So if R is equal to 0, 0 plus 1 mod 5 is 1. R is 0 in this case, 0 plus 1 mod 5 is equal to 1 mod 5 is equal to 1 is equal to 1, right? So R becomes 1, and we will insert next number here. This is the normal NQ operation which we did in the linear queue. Same NQ operation we perform in the linear queue, right? Now if we perform the one more NQ operation, let's say, so then R equal to, R is 1 now, 1 plus 1, same formula I'm using, mod 5 is equal to 2 mod 5 is equal to 2. So R becomes 2, right? The queue, of course, I'm assuming that I have checked whether the queue is full or not by using the same formula which we saw, or by using the same queue full condition, right? So R is equal to 2 now. We'll go to location number 2 and insert 30 there, right? Okay, so we perform this NQ operation like a normal NQ or normal queue, like normal circular queue, right? Now we'll perform DQ operation, right? DQ operation. Let me perform one more NQ operation, and that NQ will make R2 make R3. If I perform one more NQ operation, so what will happen? R will become 3, and we'll insert on this location. So R becomes 3, and we inserted on third location, right? So normal NQ operation. Now if I perform DQ from rear end, front end, normal DQ, it's like a normal DQ. We used to do that DQ operation from front end, from linear as well as circular queue. Same DQ I'm going to perform here on circular queue. So what is that DQ operation? We'll check queue is not empty, and then we'll say we'll get an element from front location, F is 0. So I'll say I'll remove this element by saying X is equal to data of F. So data of F is, data is this array. From data array we'll remove the element from F location. So 10 I'll remove from data array, right? And then F is incremented by 1. How I increment F by 1? By using this formula, F is equal to F plus 1 mod size. This formula we use for increment of F. That means both F and R are incremented in this fashion, in this direction, right? Both are incremented in this direction like this, right? So this is the direction. This is the direction of incrementing F and R, and this is the anti-clockwise direction, right? This is anti-clockwise direction. So F and R are incremented in this direction. So let me create some space here. Let me rub this. I just wanted to show you how F and R are incremented. So F and R are incremented in anti-clockwise direction like this. So F is 1 now, R is 3. If I perform one more delete operation, right? So I'll say remove an item from F location. So F is 1, so remove 20, f will become 2. How f will become 2? By using the same formula, right? So same formula, f is 1, 1 plus 1 is mod 5, 2 mod 5 is equal to 2, f becomes 2, f becomes 2. That is how we increment f and r. This is exactly the Q or the operations. These are the exact operation which we saw in circular Q. Q empty condition and Q full condition are also same. What is Q empty condition? Q empty, F equal to minus 1 or R equal to minus 1. That is the Q empty condition. If F is equal to minus 1 or R equal to minus 1, the Q is empty, right? The Q is empty. What is Q full condition? Q full condition, same full condition which we use in circular Q, same full condition I'll use here, right? So Q full condition there was, if R plus 1 mod size equal to F, whatever R is, I'll increment it by, I will add 1 to R's value and get the remainder. That means I am giving circular increment. This is circular increment. R incremented in circular fashion is equal to F. That means when I increment, let's say if R is, wherever my R is, I'll add 1 to that and divide that by the size of the array, right? Why dividing this by size of the array, right? When R is here, R should get the circular movement like this, right? I should get the next location in the circular fashion, right? Basically I'm checking if R is here, or wherever it is, the next location to R, whichever next location to R, is it equal to F, right? That means is the next location to R occupied by some number. How will I come to know whether it's occupied or not? If F is pointing there, then that location is occupied, right? Wherever R is, if R is here, I'll circular increment, I'll see in the circular fashion next location. The meaning of this is, right? The meaning of this is, we are checking for the next location in the circular fashion. Now till here, this will be a linear fashion. Next location to R is, next location to 3 is 4, next location to 2 is 3, but next location to 4 is 0. Whenever R is here, I should see in the circular fashion, next location in the circular fashion. That's why this circular fashion, this will give me the circular next location. So if the next location is equal to F, that means an element is present there, and that's why we say Q full. Same Q full condition I'll use in doubly ended Q also. Same Q full condition I'll use in doubly ended Q also, right? So that is these all operations are similar to circular Q. For these operations, you can watch the circular Q videos in detail. I just briefed here. Okay. So now let's come to the operations which were not there in the normal circular Q or normal linear Q. The operations of operations in which we can delete from the rear and NQ from the front. So our front is 2. Now the next operation is NQ from front. NQ from front. Next operation is NQ from front. NQ from rear, this formula, right? Now NQ from front. Now front means this, look, this end I want to NQ, right? Now usually when we're doing NQ from rear, our rear was incremented in this direction. We're saying R equal to R plus 1 mod size at this direction. Now if our front is here, can I increment front in this fashion to insert? No, because this location you can see it's occupied. This location is occupied. Then what will I do? If I want to NQ from front, I will check the next empty location in this direction, right? In this direction. And of course, when I reach here, I will check like this. I will move like this. This kind of circular movement in the clockwise direction I'll give, right? So the increment in the normal circular Q was in this fashion by using this formula for F as well as for R, right? The increment in case of this doubly-ended queue where we are enqueuing from front and rear, enqueuing from front and deleting from rear. In that fashion, in that case, our f should be incremented in f minus 1 plus max, f minus 1 plus, rather than saying max means size of this array, I'll say size, mod size, right? F, whatever f is, minus 1, because f was 2 minus 1. So this formula will again same as linear decrement till this location, right? But when our f is here, and if we want to decrement f by 1, we should go here, and for that this formula will come in play, right? So the formula, if you compare these two formula, here are these two formulae, right? F equal to f plus 1 mod size. So now rather than plus 1, we have minus 1, and we are adding this size, this extra component we are adding, right? And this mod size is same here as well as here. So this is the anti-clock, this is the clockwise, you can say decrement or increment to f clockwise. So f is incremented in this direction, rather. F is going like this, f is going like this, right? Okay, so now, so let's see how to perform NQ using front end. So f is equal to 2. So now new f is equal to, and the Q full condition can be checked by using the same previous formula, where f equal to r plus 1 mod size equal to f, right? We will call NQ only after making sure that Q is not full, right? So f is equal to, f is 2 minus 1 plus, what is size? Size is 5 mod 5. What is the 2 minus 5? 2 minus 1 is 1. 1 plus 5 is 6. Mod 5 is 1, right? 6 mod 5. When I divide 6 by 5, quotient is 1, remainder is also 1, right? So f becomes 1. F becomes 1. And then I'll insert on that location. Right? So let's say I have I have inserted 10 here. Right? Let's do one more NQ operation. F is equal to, f is 1 now. 1 minus 1 plus 5 mod 5 is equal to 5 mod 5, because 1 minus 1 is 0. 5 mod 5 is equal to 0. So f becomes 0, and we'll insert in on 0th location. So let's say 5 inserted here. Right? Now if we do one more DQ operation, NQ operation from front, so f is equal to, f, what is f? Same formula, f is 0. 0 minus 1 plus size is size of this array, which is 5 mod 5, minus 1 plus 4 is plus 5 is 4. 4 mod 5 is 4, right? 4 mod 5 is 4. So f is 4 now. You see, if I show you, f has become 4 now. That means f was 0, we were here, so we gave f the circular movement in the clockwise direction, Now f has become 4, right? And we will insert the new number on that location. Let's see. This is location number 4. This is location number 4, right? So that's how this formula works in case of NQ operation by using circular queue and doubly ended queue, right? NQ operation for doubly ended queue using circular queue. Okay, this formula. Similarly, if we perform let me create some space here so that I can write on the same page. So f is 4 now and r is 3. So f is 4, r is 3. Now the next operation is, this was the third operation, this was first, and this was second, third, and the fourth one is now DQ from rear, delete from rear, right? We are dequeuing from front only in the normal queue, right? and now we are dequeuing from rear, right? So now rear is 3, right? Rear is 3. The deletion in case of rear, in case of addition by using rear or enqueue from rear, your rear was incremented in this fashion, right? In case of deletion by using rear, our rear will increment in this fashion or it will get decremented, right? So for deletion, I'll take a number from R location. X is equal to data of R, data of R, data of R. R is 3, data of R is 40, so I'll get it out 40, right? And then I will decrement R or increment R in the clockwise direction, right? So how will I decrement this R? I should say R equal to R minus 1, right? R minus 1, but this formula, if I say R equal to R minus 1, right? Here also we decremented F. In the previous case, we decremented F because F also went in this direction. So F was decremented, right? F was decremented, right? And this was perfectly fine till we come here. But when we wanted to give circular movement like this, we have to add these two things extra, right? Minus 1 plus size mod size, right? So here also we'll decrement R, right? Decrement R by 1, right? And then add size and mod size, right? As we are going in this direction, minus 1 plus size. So R is equal to, what is R? R is 3, 3 minus 1 plus 5 mod 5, which is equal to 2 plus 5, 7 mod 5, which is nothing but 2, right? So R, which was 3, now R becomes 2, right? R becomes 2, right? So this element is removed. If we do one more dequeue operation by using this, R equal to, this formula we'll use, R minus 1, R is 2 now, so 2 minus 1 plus 5 mod 5. So this is 6 mod 5 is equal to 1. So R becomes, we'll remove this and then decrement R. R becomes 1. That is how we perform dequeue operation. So thus we perform the NQ operation from both end. This is NQ operation from both end. NQ from front, NQ from front, NQ from rear. And here we perform DQ from both, and this is DQ from rear, and earlier we performed here DQ from front, which was normal DQ operation. So I'll summarize this. Let me summarize this. So these are the NQ and DQ operations. So this is normal NQ, which is from rear end. This is normal NQ, which is from front end. These are normal operations. In normal operations, in case of rear will get incremented in R equal to R plus 1 mod size by using this formula. Here also front will get incremented by using the same formula of F equal to F plus 1 mod size. Right? So these two are the normal operations which we perform in the normal circular queue. Now these are two abnormal operations which we perform in doubly ended queue. So in case of NQing from front end, which is abnormal, NQ from front end we are not doing, we are doing it in doubly ended queue only. So here R will be decremented. R is decremented because R is going in this direction, right? Here R was going in this direction. Here R is going in this direction. That's why R was decremented. And when we reach to the 0th location, in order to give the circular movement, we have to add this size mod size, right? Minus 1 because we are going in the reverse direction. And when we come to the 0th location, in order to go in this fashion, right? In this fashion, right? This one, we have to add this size and get mod by size. Similarly, in order to perform DQ from a rear end, right? In order to perform DQ from rear end, I'm sorry, this was I'm sorry, I made a mistake here. For NQing from, so for NQing from the front end, right? So we are incrementing. So I'll show you. This is the queue, right? So to NQ from rear, we are going like this, right? To enqueue from front, if front is here, so next element will be inserted on this location. The front is incremented or decremented rather. So f equal to f plus 1, so f minus 1, because we are going in the reverse direction. F equal to f minus 1, f equal to f minus 1 plus size. Why this plus size? Because when I come here, in order to give this moment, come here, that's why this plus size mod size, this plus size mod size is to give this moment when you come here. Till here this normal f minus 1 is working, but this will come into play only when you want to give this moment, right? Plus size mod size, right? Then similarly, if you want to perform the dequeue from rear end, if our rear is here, if you want to perform dequeue, you remove the element from here and decrement r in this direction. So r is equal to r minus 1, because we are decrementing r, plus size mod size. So these two formulae are for abnormal operations. Abnormal means deleting from the rear and adding or enqueuing from the front, right? So these formulae are used. So that's how you can perform enqueue and dequeue operations on the doubly ended queue, right? So I hope you understood. You will enjoy this video, and in the next video we'll see a few more examples. Thank you for watching. See you there.